binary tree structure in array. All right, here our goal, we want to build a binary tree in an array. How to make that happen? In that array, the reason we do that, we don't want to use linked list. So we want some very easy way to store a binary tree inside an array. So that is very interesting. Okay, we need to solve this technical problem here. Okay, all right. So how to build a binary tree inside an array? So we need to use a special data structure called a heap. So it's called a heap data structure. Okay, heap. All right. First, let's look at the properties we want to have in this heap data structure. Okay. All right. So the first one, we use an array as the underlying storage object. Because although you have a binary tree structure, but you need to store it in an array. So what we basically use is still an array. So that is the underlying storage object, array. So that's the first property. The second one, near complete binary tree. So why near complete? So we know complete binary tree, right? But it's not complete binary tree, it's near complete binary tree. Okay? Because we cannot expect our heap is a binary tree. We cannot expect that. Why? Because the number of nodes in a complete binary tree is 2 to the k minus 1. But when we consider a general array, the size is n. This n may not have this form, 2 to the k minus 1, this form. If it's not in that form, we cannot get a complete binary tree. But we try to make it close to a complete binary tree, as close as possible. Okay? So we give a name near complete, not exactly complete, near complete. But what is the meaning of near complete binary tree? Here, let me draw a simple example here. So this is the near complete binary tree. Why we can call it near complete binary tree? Because other than the bottom level, okay? If you do not look at the bottom level, it is a complete binary tree, right? So the only incomplete level is the bottom level. Okay? The only incomplete level is the bottom level. The only possible incomplete level, bottom level. So for this structure, so we call it near complete binary tree. So our heap should have this structure. So we will organize our heap in this structure. Okay? So this is second property. Third one, sufficient space for dynamic data. Your heap should have sufficient storage space for dynamic data. But for this part, how do you know your space used for your heap is sufficient? How do you know it? Okay, so that may not be easy to answer. In the next slide, we will discuss this question. Because we need to spend quite some time to understand this property. All right. So number 4, certain relationship among nodes. So here the question. How do you represent a binary structure? Right? The binary structure, we know there is a root node. Under the root node, 2 child nodes, For each current node in the tree, you may have 1 or 2 child nodes. How do you address that relationship? Right? Yeah. In a given array, ordinary array, we cannot address that kind of relationship. So we need to do something more to describe parent-child relationship. So that's something we need to do. Yeah. All right. So now you understand what do we need in the heap data structure. Yeah. All right. So next, first I want to explain this question. How much space is sufficient for dynamic data? Yeah. In general, the answer, it is very hard to know because nobody can predict the amount of space to store dynamic data. Yeah. So for that reason, we need to find a solution. Although we do not know how many elements are there, but we can adjust our heap size, our array size. Okay? When we have more elements, we can grow our heap size. If we can handle that technical problem, then we can store any dynamic data. Yeah. So I want to talk about that idea in this slide. Yeah. All right. How to make array space sufficient for dynamic data. Here I only talk about idea. Okay? I describe the general idea. Okay? To make it happen, yeah, you need to write programs to implement this idea. Yeah. But for this class, we do not do that. Okay? I only give you the idea. Yeah. All right. First, nobody knows the data size for the dynamic data. So it is very hard to do any prediction. Okay? Yeah. All right. So we need to try to use a realistic way to handle our heap size. Yeah. So what do you mean realistic way? Yeah. Because someone may argue, if we do not know the dynamic data size, can we use a huge array size? Yeah. So at the beginning, we tried to create a very super big array size. It's not good because there is a lot of memory cost. If you use too much storage space, but you do not have that amount of data, so you waste most of the storage space. So that's not efficient. Okay, so we should not do that. So when we start, we should not use a too big array size. Okay. So you have to make adjustment, make change on your array size in a graceful way, in some graceful way. Okay, so that's the idea I want to talk about. Yeah. All right. Assign certain amount of space to an array initially. Yeah. Yeah. So initially, you know the number of elements in the current array, right? So you can assign suitable amount of space to the array. So not very big, okay? But after that, you need to prepare to change the size in a graceful way. Yeah. Yeah. So what's that graceful way? Keep adding data and monitoring the size closely. Yeah. If your array has enough space to hold new data items, you do not need to do anything. Yeah. But you need to keep checking. Yeah. You need to make sure you do not get overflow. Yeah. Sooner or later, you may have overflow. So you need to know that point. Then you need to fix it. Yeah. All right. When a threshold is reached, array size, the limit is reached, a new array with larger size is created. Now you need a new array. Yeah. The old array you cannot use because we know in any programming language, as soon as we create an array, the size is fixed. Okay? So you cannot enlarge its size. Yeah. But we have some dynamic data structures. In Java, in other programming language, you have some dynamic data structures. Yeah. But here, so let's consider that because the dynamic data structure, how is it implemented? It used ideas similar to what we are learning here. So we just learn how to implement a dynamic data structure. Yeah. All right. So create a new array with larger size. Okay? Yeah. So you change the size. Then you do the data copy. You copy your data from old array to new array. Now you have more room to hold more data items. So that simple idea. Yeah. But this copy step, data copy step, usually is very expensive. Expensive means when you make that copy, it takes a lot of time. Yeah. It takes a lot of time. So it will slow down the whole insertion performance. Yeah. So that will happen. Yeah. So that may not be very good. Yeah. So in your real application, you will experience significant slowdown when you have this kind of thing happen. Yeah. All right. So here, so let me try to go a step further for this situation. So usually it is very expensive to copy a large data. So your data size could be very large. So you copy from one array to another array. You know, you may take some time to do it. Yeah. All right. So here you may have the situation. Yeah. So here I use this curve to represent the situation we have. Okay. Usually, when we have a new dynamic data, we do insertion. We do not spend much time, right? Yeah. But when we reach the size limit, we need to create a new array and copy the data. Suddenly, we need to spend more time on it, right? This is, the time we spend. Yeah. Suddenly, yeah. So we hit a big bump. Okay. Yeah. Yeah. So from the appearance, you will see the program slows down significantly. Yeah. It's a bottleneck. It takes much longer. So normally you see things running smooth. Suddenly you experience very slow. Okay. So after that, then you can get a faster performance. So that is not a good user experience, right? So think about when you do something, suddenly in the middle, you have to wait a few seconds. So that's really bad, right? So we want to avoid that. Okay? So how to avoid it? Yeah. So there is a solution. Yeah. We try to find a way to spread, this bump. When we detect, we will near the array size, right? After you add dynamic data, item by item, you are closer and closer to the array limit. Okay? Then before you reach that limit, yeah, so you give some room. Before you reach that limit, you start doing preparation. You start doing data copy preparation. You prepare ahead of time. Okay? Yeah. So you create a new array. So then you copy data, but you do not need to copy all the data at the same time, right? Yeah. After one data insertion, then can you copy 10 data items? The second insertion, can you copy another, 20 data items? Yeah. Try to find that number. You make that copy to the new array, right? So you copy. So you will use a little more time, but not too much more time. Yeah. Not the big bump, small. Yeah. So a little more time than usual. You look at the curve here. A little more time than usual. Yeah. But your users will not experience significant slowdown. Yeah. Slightly slower, yeah, but it's okay. They can still do the normal work. Yeah. So in this way, this idea, if you can implement this idea, then you can solve the problem. Okay, you can solve this big bottleneck problem. Okay, yeah. All right, yeah. But for this class, we do not have chance to implement this idea, because to make this idea work, you need to spend a lot of time, write a lot of code. It's a very interesting idea. Yeah. All right. Yeah. So let me stop this video. We will continue to study more properties of our heap data structure.